Yeah. Good afternoon, everyone. We will start our session. Good afternoon. We'll start our session for today. In the last class, we were discussing about different theoretical concepts about in C, keywords, variables, data types, tokens, character set of C, etc. And data types we saw in detail. 5 primary data types: integer, character, float, double, and void. Except void, all the other four data types are used for creating variables. Then variables are used for storing data. Data stored in variables, they are processed to get the desired result based on the problem we are trying to solve. In the simplest problem we have taken adding two numbers, we got two integers and added it and displayed it. For we got two input integers from the user using scanf function, then added it using an expression s equal to x plus y, s equal to x plus y. Then the result is printed using a printf function. Two ways we printed the result. The result is percentage d. Okay, thank you for reminding me. Again, I was not demonstrating much. Just the meeting view was there. Yeah, I keep forgetting it, and don't hesitate to remind me. So we took two inputs. We asked the user enter two numbers. When user entered two numbers using scanf, we read that or accepted or scanned those two numbers into our program. Accepted those two numbers into our program and stored in x and y. So syntax of scanf, many people who are new to programming, they are struggling still. Please be very comfortable with the syntax of scanf. Here we are accepting two integers, that is why %d. When we want to accept two floating point numbers, we will use %f, %f, and the variable type should be float. Okay, likewise what we did here in the second program. So syntax of scanf, be very thorough with that, and syntax of printf. You are going to use these functions in almost every program you are going to do in the lab or in your programming life using C. So be very comfortable with this, and how we are printing the sum of 10 and 15 is 25. How we are printing it. Three placeholders %d. The first number 10 will come here, second number 15 will come here, and the result will come here. And the variable which stores 10, the variable which stores 15, then the variable which stores 25. So finally, this printf function is responsible for creating the final string. Here we have given a placeholder or a template or a say gap. We reserved the space for one integer value, second integer value, third integer value. Printf function will put the actual integer value stored in x, y, or and s. Okay, if you directly put some 100 here, definitely this will go into the place of the third %d. It need not be always variable here. You can put a constant also. This is a constant. If constant means that same value will go into the place of %d, the third %d. Okay. But our program requires that to be a variable, and the value stored in the variable will be placed there. Okay. These things are very clear, and we are moving on to the next topic. After data types, the next major topic is operators. Operators are yeah, tell me. Actually, if you use a virtual keyboard, and you can find that it is already there. How do I show? In all Android phone, it is there, and symbol. In the uh, okay. It should be there. Probably you are using an Android phone. And Android phone, or which what type of phone you are using? Okay, you send me a message and I'll show you, and you can install some keyboards or keyboard from Play Store, new keyboard if it is not there in the default keyboard. You send me a message to my WhatsApp. I will show you, send you a small video how you can find that ampersand symbol. Okay, or your friends only can help. Okay, if somebody can quickly help her after the class, send a screenshot how to get access this symbol. Okay. So now we are moving on to operators. Operators, we have already used some operators. Operators are basically arithmetic operators. Then there are some operators called logical operators. Similar to operators you have encountered in mathematics. There are a lot of similarity between mathematics and programming. I told some time back about y is equal to f of x, where f of x is x square plus x plus some constant. So we f of x, instead of that in C we write a function. We can that a lot of correspondence is there, and we can pass some arguments into a function. A lot of correspondence between mathematics and C or programming language. So operators are, we have used certain operators here. Addition is an operator. This is assignment operator. This is called address operator. Okay, these are the operators probably you can quickly recognize in this program. And see, there are several operators, maybe dozens of operators are there, and in this topic we are going to learn about operators. We'll start with arithmetic operators, basically addition, subtraction, multiplication, etc. Very similar to mathematics. And there are additional operators in C which you might not have studied in mathematics, but in programming, most of the programming, these operators are there. Now, if you learn in C, it will be easy to understand in another language. So, most of the operators are common across different languages: C, C++, Java, Python, etc. Okay. So, operators are essentially those mathematical symbols used for performing some operations in your programming language. And these are the categories of operators: arithmetic operators, relational operators, logical operators, assignment operators, yeah, increment and decrement operators, conditional operators, bitwise operators, special operators. These are the 8 categories of operators available in C. Okay, there are some other operators are also there. Probably we will not learn by including in some category, but in the process of learning the language, we will learn. Example, ampersand is an operator actually. It's called address operator. We will not learn it here, but you have already somehow used in your program. So it doesn't matter much whether you include into a particular class as such. Okay. But as far as the syllabus or the textbook is concerned, these are the categories of operators. Arithmetic operators, you are already familiar: addition, subtraction, multiplication, division. So multiplication in mathematics, we normally use a cross symbol, but in programming, most of the programming languages or all the programming languages I know, multiplication is performed using star instead of that cross. Basically, that cross is not there in the keyboard also. If you put, actually if I put it using X, this is X, but cross is not there in the keyboard, standard QWERTY keyboard available in your laptop. Okay, so most of the programming languages I know, or all the programming languages which I know, they are using star symbol, or it's also called asterisk. This symbol is also called asterisk. This was not there, so there in the special characters set of C, which we studied in the previous sessions or previous topic. So these are the arithmetic operators. Working of these operators, addition, subtraction, multiplication, division, it is similar to what is there in mathematics. And probably this is the one you are not familiar. It is known as modulus operator or modulo division. So we will come to all of this. And these operators primarily work on numbers. in mathematics also we perform addition, subtraction, these operations on numbers. Numbers may be constant values like 5, 10, etc. or it can be variables which stores some value. So these operators can act on numbers. Numbers, we have two types of numbers as we already know, integers and real numbers. So integer we represent using int or create variable using int, and real numbers we create variables of real number type using float or double. So operators uh, act on numbers primarily. And there is another operator called modulus operator. We will quickly see, since it is familiar, these are familiar, we will not spend much time on this. So integer arithmetic, if x, let x equal to 77, y is equal to, it's similar to mathematics, x plus y, z is equal to x plus y, it reduces 32. That is equal to x minus y gives 22, 27 minus 5. So similar to mathematics, your x into y, so 135, x into y. Then x divided by y, 5. Yes, I am assuming that both are integers. These x and y are integer variables. Integer variables. X and y are integers. And z is also x, y and z. All are integers. Variables. So I created int x comma y comma z in my program. I would create like that. So x by y, x divided by y is 5. It is not 5.4. It's not 5.4. It is 5. Okay. So since this is integer, this is also integer, the result will be an integer. Even though sometimes we expect in mathematics the result of x by y as 5.4, since x is 27 and y is 5. But in C, the type of the variable, so we call these x and y as operands, and this as the operator. So these are all binary operators having two operands. Binary operator means that operator is having two operands. So plus is having x and y, two operands, minus also binary operator x and y, like that. So when we are dividing x by y, the result depends on the type of x and y. X and y, if x and y are integers, the result is also going to be an integer. So it is not very much like mathematics. Probably you would have expected 5.4 as the result, but in C programming it is 5. This concept is more important. Like this part is important. Sometimes you will get confusion. Okay. So since these two are integers, the result will be an integer. And even though we expect 5.4, that 0.4 will be discarded or truncated and rounded off, and we get 5. Okay, so these are the familiar operators, and we have the fifth operator, arithmetic operator, called modulus operator or remainder operator. Okay, or modulo division. Modulus operator, sometimes called remainder operator or modulo division. Can anyone tell what it is giving? When x is 27 and y is 5, the result I got is 2. So what can you guess what x mod y? I will read it as x mod y. What is the result? Not exactly. Basically, from the name you can infer it. Modulus operator, modulo division, or remainder operator. I'll put a third name as well. These are three different names for this operator. So now maybe you can give a better guess. When you divide 27 with 5, what is the remainder? We are doing integer division. We already quotient we got 5. So if quotient is 5, we have remainder as 2. So this remainder operator gives the remainder of remainder if x is divided by y. If x was divided using 5, x means 27. 27 was divided using 5. What would have been the result, the remainder we are getting? Same thing. When we are generalizing, when we divide x with y, what is the remainder? That is what is given, provided by the remainder operator. So x mod y, we read it as x mod y. We get 2 as the result. The 2 will be stored in z. Okay. So I can ask you some more. Instead of variables, I am going to put some constants. Say 10 mod 2. Oh, whatever is my mode. 10 mod 2. What will be the output? If you divide 10 with 2, what is the remainder? Quotient, it's not quotient. I am asking what is the remainder? 0. So this is going to give me 0. This operator will give directly what is the remainder when you are dividing the first number using second number. This will give you the quotient x by y. Quotient is basically division. This integer division is giving me the quotient, and this is giving me the remainder. As simple as that. So I am going to divide again 13 mod 5. What will be the result? When you divide 13 with 5, yeah, you get quotient as 2 and remainder as 3. So 3 is the result. Okay. So this operator is somewhat different from the other 4. Maybe not familiar to you. Maybe mathematics also there is no such directly such operator. Basically, it is an easier way of doing it, getting the remainder of a division. Okay. So this will give us the quotient only. So somehow we want the remainder also. We get this way. Okay. So yeah, we have some more examples here. Okay. Let this be there. Next time when I teach, I can ask it as question only. So for this modulo division, some properties are there. It works only for integers. In C, it works only for integers. That means both operands x and y should be integer. Okay, not real numbers or floating point numbers. Then x mod y gives the remainder of integer division x divided by y. Okay, we have some examples here. X is equal to 10, y is equal to 3 I am taking. Then x mod y is 1. That is 10 mod 3 is 1. Quotient is 3, but remainder is 1. So x mod y is 1. 10 mod 5 is 0. Already we saw. 13 mod 8. 5. If anybody is having a doubt, 13 mod 8 is 5. Because quotient is 1 when you divide 13 with 8. Then what is remaining is remaining or the remainder is 5. Then for negative values also it is there. So minus 10 mod 4 is minus 2. If you remove the negative part from here, 10 mod 4 is 2. 10 mod 4 is 2. But since this value is negative, minus 10 mod 4 is minus 2. Now 10 mod minus 4, it is 2. Minus 10 mod minus 4, it is minus 2. Basically, if you get a question like this, minus 10 mod 4 or 10 mod minus 4 or this way, you remove the sign and find the remainder. You ignore the sign, negative number, consider it as positive number and find the remainder. Then apply the sign of the first operand or the numerator in division, first operand or numerator, that will be the sign of the remainder. Sign of modulo division result is sign of the first operand. Here all the three places you can see that property is maintained. Minus 10 mod 4 is minus 2. Minus 10 mod minus 4 is 2 because sign of first operand is positive. Then minus 10 mod minus 4, that is also minus 2. Okay. So remainder operator is clear. I'll quickly ask some more questions. 14 mod 3. 14 mod 3. 2. Because quotient is 3. 4 into 3, 12. So 14 minus 12 is 2. Then 5 mod 10. I'll write it here. 5 mod, or okay, let me start with 10 mod 10. 0. Exactly divides. Now I'm going to reduce it. 9 mod 10. When you divide 9 with 10, integer division, what is the quotient? Quotient 9 by 10. Quotient. No, 9 mod 10. What is the quotient? 9 divided by 10. What is the quotient? 9 divided by 10. When you are doing integer division, the quotient is 0 and the remainder is 9. So 9 mod 10 is 9. Clear? Same rule we are applying. We are dividing. We are ignoring the quotient. We are taking only the remainder. So 9 by 10. 9 divided by 10. Quotient is 0. Remainder is 9. So any number less than, say this way, 3 mod 10, you get 3. Quotient. We are looking for quotient. So any number less than the second operand, if you perform the mode with that, for that, you get the same number. 4 mod 10, 4. Then 10 mod 10, 0. The moment it is larger, we start getting different numbers. Okay. Is it clear? And one more property. When I am performing mode with 10, there is another property. It is same for smaller as well as larger. 5 mod 10 is 5. 7 mod 10 is 7. 10 mod 10 is 0. 12 mod 10 is 2. Can you identify that property when I am finding with mode with 10? Any number finding mode with 10. What is the result I am getting? There is a property or pattern. Again I will execute. 15 mod 10, 5. 25 mod 10, that is also 5. 26 mod 10, 6. What is that pattern? Can you identify that? No one is getting. I get the number, the units position digit of the first operand. Whenever I do 727 mod 10, I get 7. So the unit position digit of the first operand I am getting when I am finding mode with 10. Is it correct? Can you recognize that? Okay. So any positive number when you are finding mode with any positive number when you are finding mode with 10, you get the units position digit of the first number. So this property we use sometime later in programs and all. Whenever we want to extract the digit at unit position of a number, given number, we apply this mode 10. Not unit digit, unit position digit. The digit at unit's position. Yeah. 5 more 10 is 5 only. 5 more 10. Quotient is 0. Remainder is 5. That's what we started with, right? Any number less than the second operand, you get the same number as the remainder. Okay. So these are some properties of modulus operator. You might get a multiple choice question in your lab viva and all regarding this. So I hope this is clear to everybody, or you can ask it out. Those are the arithmetic operators, and we were seeing mostly integer operations. The same thing applies for floating point numbers also. Now floats x is equal to 114 and y is equal to, so same syntax, z is equal to x plus y. So same syntax, we get this result. Now here we get a floating point result. Our assumption is that x is a float and y is a float. So x divided by y, it is going to be a floating point number. This is not any more integer division because the operands are of floating point type. The result is also going to be a floating point type. So at least one of the operand is of floating point type. The result will be of floating point type. Okay. So here we get 3.5. I don't know. I just for, is it x by y? Is it 3.5? Oh. Yeah. It's 3.5. And modulo division works only for integers in C. So this you note down. For floating point numbers, modulo division does not work in C. Okay. Why I say in C is because it works in Python. In Python, for floating point numbers also, real numbers also, it works. So since we are learning C, I'm just telling that. Okay. Then mixed arithmetic. This floating point can be a double. So these are basically real numbers. Okay, floats or doubles. Real numbers. Okay. It can be float or double. We can apply all these operators except modulus operator or modulo division. All others we can apply. Okay. We have some questions here. So mixed arithmetic. Mixed arithmetic means your operation involves two different data types. So example, an integer. The numerator is an integer. Denominator is a real number, float or double. Okay. Here the result will be different. Normally we will expect same result in mathematics. We will expect the same result 1.5. When I am dividing 15 with the 10.0, I will expect 1.5. Here also we will expect 1.5 if it is in mathematics. But in C programming, the result of the operation depends on the data type. Now when both numerator, both operands, I can say both operands of this division operation, if they are of same type, the result also will be the same type. So in this case, applying that, can you tell me what will be the result? 15 divided by 10. Silence. These are integers. I am telling these are integers. Your result is also going to be an integer. So 15 by 10. What is the result? 1. Because 1.5, mathematically we will get 1.5. But since both the numbers are integers, the result also has to be an integer. That 0.5 will be discarded and the result will be 1. But in this case, it is slightly different. One is integer, another is floating point type. In that case, the result will be of float, because integer and float, when you compare, this is of higher grade, I can say higher caste or higher grade. So when there is an operation between a lower grade of data type and a higher grade data type, the result will be of higher grade. So in this case, 15 by 10, 1.5, but one of the operand is a floating point type, so the result should be of floating point type. So the data 1.5 from 1.5 is not discarded. So in this case, the result is 1.5. In this case, the result is 1. Okay, we can experiment that. So what I will do, I will put result. Okay, let result be float. Each time we'll have the result as float. Then I'm going to perform 5 by 10. 5 by 10. And since it is a float, I have to use percentage %f for display. So in this program, the result will be, okay, there is a problem. What is that? Okay, I did not compile it. Yeah. Okay, that is also an interesting thing. So I get the result as 0, even if I compile. Okay. So how will I tell you why this mechanism is happening? Okay. So I'm getting 0. So I'll tell you soon why it is happening. Actually, yeah, it should be 0 only, right? 5 by 10 I'm doing. So I should have done 15 by 10. Then it will not create confusion. Yeah. Result is 1. Result is 1 because 15 and 10 both are integers, and the RHS will be computed as an integer, and that means from 1.5, 0.5 will be discarded, and the result will effectively become 1.0 or 1. When 1 is assigned to a floating point number, it is as good as making it 1.0, and you get the result as 1.0. Okay. So 15 by 10 giving me 1.0. Slightly I make a change here. 15 by 10.0. 10 and 10.0 are essentially same in mathematics, but when we are computing that, we get the result 1.5. Okay. Yeah. Hmm. No, that is a different story again. Here, let's focus only on the RHS. Let's focus only on the RHS. Okay. Let's ignore that. What is the type there? Now, this difference are you able to recognize? 15 by 10 is 1 because RHS both operands are integer type. Result has to be an integer. So instead of 1.5, that 0.5 is discarded, and we are assigning it to a float. Now when it is 10.0, one operand is of higher grade, so the result will be of that higher grade data type, say floating point. So 1.5 value is retained. RHS is evaluated to 1.5, that is stored here and that is displayed. Okay. Now I am going to change to integer. Your question is this. Okay. So since it is integer, I have to print it using %d, and here is the interesting thing. I get the value 1. I told just now this is going to get evaluated to 1.5. because this is floating point type, this is integer, this is having higher grade, the result will be of higher grade. Now in fact this is evaluated to 1.5, RHS is evaluated to 1.5, but when you are assigning a floating point number to an integer variable can store only integers. So after the result evaluation, when we are assigning, what is getting stored in result res variable is going to be an integer, because it's integer type. Integer type can store only integer, or whatever you store in an integer variable, even if it is having a floating point part, that will be discarded. So because of that, we are going to get the result 1. That's why the importance of floating point type there. Okay. Clear? So in this case, the result evaluated is 1.5. That is consistent with what I told you earlier. But since I am assigning that result to an integer variable, again that data is getting lost and it is truncated to 1. Yeah. So here it is evaluated. So first the basic principle is whatever may be in the left hand side. This is the left hand side of the assignment operation. This is the RHS. This is LHS, RHS. First RHS will be completely evaluated. So even if here, okay, here there is no confusion as such, because 15 by 10 it is anyway going to be integer division only, both are integers. Because of that the result is going to be 1 only. RHS will be completely evaluated, that means it is as good as putting like this. Okay, now the other possibility is, what if I put float here? What do you expect? Just think that I told one statement, whatever may be in the LHS, RHS will be completely evaluated. Finally, one value will be there that is going to be assigned to this. So here in RHS, I have an expression having two integers. So as per the rules we learned so far, since they are both are integers, the result is going to be an integer. That means we are going to get RHS side, we are going to get 1. Now when I assign 1 to RES, it is a floating point type, it will become 1.0, no difference. Okay, so two things to remember, only 2 things to remember, or 3 things to remember. Result of an expression, say it's an operation. If the data type of the operands are same, the result will be of the same type. Now if the data types are different, the result will be of the type of the result will be the type of the higher grade operand. So here it is, higher grade is this. Okay, now whatever may, so RHS in an expression like this, say x is equal to y into something, so there is an LHS as well as RHS. RHS will be completely evaluated as per the previous rules. I told 2 rules, and finally the result will be assigned to the LHS. Okay, so if you apply those 3 things, it will be clear what is going to be the output each time. Okay, any question? So here the result is going to be 1.5. Here the result is going to be 1. Now I have a similar expression there. Same question. 15 divided by 10.0. And what will be the value of C? I already explained it. So now you can. No. This here LHS, it is an integer variable. So RHS is completely evaluated. RHS is 1.5. But when we are assigning in the left hand side, a variable is of integer type. It can store only integer. 1.5 is not an integer. So 0.5 is thrown out. Okay. So this is going to give, C is going to get the value 1. Now here 15 by 10 and I am assigning it to F. what will be the value of f? Yeah, it will be 1.0, because here RHS is, I told RHS will be completely evaluated. So 15 by 10 both are integers. Result is going, RHS is going to be an integer. That means from 1.5, 0.5 is discarded and 1 is only remaining. When 1 is assigned to f, it will become 1.0. So here it is going to get the value 1. Here it is going to get the value 1.0. 1.0 and 1 same only. Just this is an integer, this is a real number or floating point number. Is this clear? Or you can ask any question. Anybody, it's not clear, you can ask question. Yeah, floating type, basically value wise there is no difference, but how it is treated internally, it is treated as a floating point number. But 1 and 1.0 value wise no difference. This is an integer according to C, but mathematics we treat both of them are same way, because magnitude is same. 1.0 magnitude is same. But in C, when internally it is stored differently, treated differently. Floating point number. Yeah. So those are only like that much about arithmetic operators, and I have shared the notes for this topic, the part 3, unit 1, part 3. See, part 2 and part 3 are we are covering. Part 2 already we covered. Part 3 now we are covering. Part 1 I have not covered in class. That is again theoretical topic. So we will cover it afterwards. Okay, after part 3 or maybe after getting into module 2 later. Before the first test we will cover that. So that is totally different topic, and you are not dependent on that for learning these things, the current topics. Okay, 320, 230 to 320, right? So I should be stopping. So next set of operators are relational operators: less than or equal to, greater than or equal to, is equal to, not is equal to. These are the relational operators. These are used, maybe in mathematics you are familiar about this symbol less than, say x less than y and all. These are used for comparing numbers. Okay, if 5 less than 10 or x less than y, or x less than or equal to y, or y greater than z, like that. For comparing two numbers we use two numbers or two data values, primarily two numbers. We'll see about this in the next class. And you can those who did not understand modulus operator or what I taught in the previous slide, you can further go through those notes. Okay, and we'll see in the next class, so we can take a small break. Anyway, this set of operators are totally different, and we need to start it from scratch. Okay, then we'll see you in the next class tomorrow. Thank you.